Hi guys, so this is gonna be just a quick video trying to think about this problem. So just want to think about like we kind of want to figure out what are all the real orthogonal 2 by 2 matrices, and we're gonna show that either it's like cos theta, negative sine theta, cos theta, and if you think about it, this is like this is like a rotation. Um, a rotation by theta. I guess it should be. I'm not sure if it's. I don't remember if it's clockwise or counterclockwise. One of the two, anyways. Okay, so this one turns out to be a rotation, and this one turns out to be like kind of like a rotation and reflection. Um, Rotation and reflection is just another way of saying like reflection across some different axis. Okay, so this is like a reflection, this is a rotation. Okay, so let's figure out how we can prove that any real orthogonal matrix has one of these two forms. Okay, so solution, the Q be a 2 by 2 real orthogonal matrix. So it's just a 2 by 2 matrix such that Q transpose Q equals the 2 by 2 identity. Let's just call the first column, let's call it AB. Okay. Now, what do we know? Well, first of all, we know that a squared plus b squared square root equals 1. So a squared plus b squared equals 1. One way to think about that is, well, the columns of Q have to form an orthonormal basis for R2. In particular, the norm of the first column has to be 1. Okay. Now, if C and D is if this is the second column, then CD has to be orthogonal to AB. So we have AC plus BD equals 0. So that means we can write CD as some multiple of the vector. I'll write it not. Let's say some multiple of negative BA. Okay, right? Because any vector that's orthogonal to AB has to be a multiple of negative BA. Okay, so it's just something times mu. Finding the norm, so the norm of CD has to be 1. So the norm of this vector, well, that's just absolute value of mu times norm of negative BA, which is a squared plus b squared, which is absolute value of mu. Okay, and this needs to be 1 because we need to have an orthonormal basis. So mu has to be either 1 or negative 1. So the second column is either, one possibility it's negative BA, or another possibility it's B negative A. Okay, so far, what can we say about Q? Q looks like either AB negative BA or AB B negative A. Okay. So now the trick is, you can see like, if we try and match it up with what we're trying to show, we're almost there. In this case, we just need to show that if a squared plus b squared equals 1, then we can write a equals cosine theta and b equals negative sine theta. Or we can write a equals cosine theta, b equals sine theta. Okay. So, now given a squared plus b squared equals 1, we can find angles, we'll call it theta and psi, for example, such that a equals cosine theta, b equals sine theta, and we can find psi such that a equals cosine psi and b equals negative sine psi, right? And you know, if you think about it, I guess yeah, if you draw like some triangles, this will make sense. So in the first case, we get so in the case where we have the AB negative BA, you get cosine theta. Oh wait, I want this to be A B B negative A, and you put it in this, you get cosine theta, sine theta, negative cosine theta. That's one of the forms, and then in this case, you get cosine psi, negative sine psi, sine psi, cosine psi. That's it. And that's it. Okay, thanks.